Hi and welcome to this video all about NumPy. So let's start by just going through what we are going to do in this section. So every lecture has lecture notes, which you can find in either the folder you were asked to download at the beginning of this course, or you can find the specific lecture note to this lecture in the resources. So all the functions we are going to go through together with the package it belongs to, you can see in the list on the top of the lecture notes. So here you have what we went through the last lecture. So we went through code cell, which we can run then by Shift-Enter. We went through markdown cell, and here in this link here, you can see all the notation for instance, getting boldface or italic text, and you can also write math into the markdown cells. As always in Python, if you want to find help with a specific function, you can write help and then the function, and it will give you the docstring. So let's run this cell, and here you see the docstring about the sum function. So sometimes the docstring is helpful, especially if you know a bit of Python from before, but sometimes it's a bit complicated, especially when you don't know a lot of Python beforehand. So let's go to the topic of this video, namely the NumPy package. So the NumPy package is a package for numeric computations in Python, and it contains a way to create vectors and matrices in Python. So let's start with just going to the web page of NumPy. So here is the NumPy web page. So what it tells you is that it's powerful and fast and versatile, for instance here, especially for doing numeric computations. It's a numerical computing tool, open source, and a lot of other good stuff. So up here you also have the Learn page, where it gives you a very quick introduction to NumPy. So if you go through the course and are interested in, for instance, a beginner tutorial on NumPy, you can go here. But we also have a NumPy course here on Udemy that you also can go through if you want. But here there are plenty of free NumPy tutorials if you want to learn even more NumPy. So let's go back to Jupyter Notebook. So the first thing we need to do is to install NumPy. But luckily, since we are using Jupyter Notebook, this is not needed because NumPy is already installed together with the Anaconda environment. So the only thing we need to do is to actually import the package. And the usual way is to import the NumPy package with the alias np. And the reason is that it contains a lot of function, which is also contained in, for instance, the math package. And if you use both, there will be conflicts between them. So we write import NumPy, that means the NumPy package, as np. And then we can run this cell with, for instance, Control-Enter or Shift-Enter. So now the NumPy package is imported. And the basic things that the NumPy package contains are the ND arrays. So a 1D array is going to be what we know from mathematics to be a vector, and a 2D array is going to be a two-dimensional array, also known as a matrix. So we are first going to go through how to create the vector and how to work with it, and thereafter we are going to go through matrices and how to work with them as well. So let's say that we want to create the vector A containing the numbers 1, 2, and 3. So what we can do is to write np. Remember, this is what we called our NumPy package. And then we can use the array constructor. And then inside here, we can, for instance, write the list. So let's take the list with the numbers 1, 2, 3. And if I run this cell, I have created the vector A here. And now you see that it writes array around the list with the numbers 1, 2, 3. Okay, so for what I'm going to do today, I will need two vectors. So let me define another vector B, exactly the same way. But this time I want it to contain the numbers 4, 5, and 6. So let me run the cell again. So now I have both my vector A and my vector B containing the numbers 4, 5, and 6. I said that the 1D arrays are vectors, and what we know about vectors are that we can, for instance, sum them. So we can write A plus B, and then if I run this cell, I end up with the sum of each number. So for instance, in first entry, I end up with the sum of 1 and 4, which is 5. In the second entry, I end up with the sum of 2 and 5, which is 7. And in the final entry, we end up with the sum of 3 and 6, which is 9. Okay, so this is just the standard vector sum that you learned in mathematics. And here you see that the 1D arrays are actually different from a list, since if we try to take the sum of two lists, we don't get the sum of each entry. Other things we can do is to do the scalar multiplication or multiply a vector by a number. So for instance, I can write 3 multiplied by A and then just run this cell. And what happens is that I get the first number here multiplied by 3, which is 3. The second number 2 multiplied by 3, which is 6. And then 3 multiplied by 3, which is 9. So this is what happens when we try to take our vector and multiply it by a number. Okay, so there are several different things we can do with vectors, but I'm going to leave it at that. So the most important things is that 1D arrays looks like this. They are just vectors. We can add them and we can multiply by scalars, and that's it. One thing I would just like to point out when it comes to vectors is that all the things inside the vector needs to be of the same type. In list, we can, for instance, have one number and then one string, and nothing really breaks. But in 1D arrays and also 2D arrays, and more generally ND arrays, which we are not going to talk about, all the things need to be either all numbers or all strings or all Boolean values and so on. So all the things inside a vector needs to have the same type. So if I, for instance, try to change here with having a string, run this, you see nothing really happens. But if I run this cell, it has converted 1 to a string as well. So it has made all the things inside the array to strings. And the reason is, as I said, all the things inside the array needs to have the same type. So let me make it back to a 2 and run this 2 cells once more. And now we have the numbers. So let's move on to 2D arrays, which I'm also going to call matrices. So let's create a matrix. And we are going to use the np.array constructor once more. But this time we need to plug in a list of lists. So let me write 1, 2, and 3 for the first row. And the second row is going to be 4, 5, and 6. So if I run this cell, I have created my matrix, and let us just display it. And we see that the first row of this matrix is 1, 2, and 3. And on the next line, it displays the second row, which is 4, 5, and 6. So again, what we can do with matrices are, for instance, multiplying by a number. So we can write 5 multiplied by matrix. And what we get is all the numbers in the matrix multiplied by 5. For instance, 1 multiplied by 5 is 5, 2 multiplied by 5 is 10, and so on up to 30 here. So let's call this new matrix like this. And we can also add two matrices together. So for instance, we can take the matrix plus new matrix. And what we get out is the sum between this matrix here and the old matrix. So a matrix is also called a 2D array in NumPy. There exist also 3D arrays, 4D arrays, and etc. Where we have, for instance, instead of a list of lists, we have a list of lists in the creation of a 3D array. Okay, so the final thing I want to do is to just check the shape of a matrix and a vector. So what the shape does is, for instance, here we have 3 numbers in the vector, which makes this a free vector. And here we have 3 columns and 2 rows, which makes this into a 2 by 3 matrix. So for instance, if we take A and dot shape, we get out 3 here because there are 3 values in the vector. On the other hand, if I write matrix dot shape, I end up with 2 comma 3. 2 because there are 2 rows, and 3 because there are 3 columns. So this is a very simple way to just check how many rows and columns there are in the matrix or how many entries there are in the vector. So the reason we care about ND arrays is because they contain the data which we are going to plug into our machine learning model. Okay, but sometimes our data are not just numbers. There can, for instance, be Boolean entries and string entries and different other things. And then we cannot work with NumPy. As I said, in NumPy, all the things are just one type. So then we need to work with Pandas instead, where all the different columns can have different data types. Therefore, we will, in the second video, work with Pandas a bit, just for the cases where we have different data types in different columns. So see you in the next video for a short introduction to Pandas. In this video, we are going to learn about the Pandas package, which you can see here. And the Pandas package contains what is called data frames, where each column in the data frame can have a different type. Again, we have a getting started page, which you can see here, with a bunch of tutorials, which you can find here. And this here explains to you how data frames work. And if you think that you need some more practice with data frame after seeing this video, then you can go to the Pandas webpage and just go through the tutorial. Okay, so let's go into Jupyter Notebook and go through data frames. So in general, the first thing we would need to do is to install the Pandas package. But since we are working with Jupyter Notebook, which has already installed it for us, we can just import it. And the usual thing is to import the Pandas package with the alias PD. And reasoning is essentially the same as with NumPy, that you don't want conflicts with the other packages. So it's always best to import things with an alias when you want to import it. So we will write import pandas as PD and run this all. And now we have imported the Pandas package. Okay, so let's start with manually creating a data frame. So for the most part, we will just import a pre-made data frame from somewhere else, but it's possible to make it manually. And this is done with the PD dot and then the data frame constructor. And inside here, you give it a dictionary. Then we can have the first column to be A, and this is going to contain the numbers 1, 2, 3. The second column is going to be called B, for instance, and here we can have another data type, for instance, Boolean data, true, false, false. And the third column, we can call it C, for instance, and let's make it a string, and let's have hi there, and another kind of greeting, let's take howdy. And finally, we can have a non-value. So non-values are allowed even though it's not a string, because we can have missing data in our dataset. Okay, so let's run this cell and let's return it so that we can view the data frame. So when we just return things, then Jupyter Notebook will show it rather pretty, and you see that it's sort of interactive, where if you hover over a row, then it will mark it in blue here. So what you see is that the first row contains the first element 1, and the first element of the Boolean data, which is true, and the first value of the C column, which is hi there. And the same is true for the second column, which has index 1 in Python, and also the third column with index 2. So what we will often do is just to select one column and work with it. And there is a couple of ways to do it, but most often what we are going to do is using the following way, where you take the square brackets and then you can write in the name of the column you want to get out. For instance, here you get out the A column, so that is this column right here. And if we run it, we see that we have selected the first column. And we can do the same with, for instance, the second column. Just write the name of the second column here and run it. And we see that the second column has now been chosen. And it also gives you some information, for instance, that the second column is a Boolean column. Okay, so a very nice thing about data frames is that there are several very useful functions which can give you a lot of information about them rather quickly. For instance, we have the describe method or function, which will give you a lot of statistical information of the numerical columns. So we can write df.describe and let me use the tab for autocomplete. We describe here, and since it is a method, let me have the parentheses and run this sum. And here you get some statistical information. So in this case, only the first column is numerical, which means that we only get statistical information of the first column. And what it does is, for instance, to say how many elements there are, give out the mean, the standard deviation, the minimum and the maximum, and also the quantiles. So the first quantile, the second, and the third quantile here. And the second quantile is also sometimes called the median. So describe is a very useful function which we are going to use a lot when exploring the data frames. Describe only gives you information about the numerical columns, but we have the info method, which gives you some information about the other columns as well. So let's use the info method. And here you see it gives you out the type of each. For instance, the 0 column or the A column is int 64. The second one is Boolean, which is called B, and here you also have the column numbering. And the third one is what is called the object, which is the most general class. And here you see that it only contains 2 non-null values. So what it's referring to, so this 2 here means that here we had a none value, and it is only counting the non-null values. So it's counting 1, which is hi there, and 2, which is howdy. And this one is not counted in this column over here because it only counts the non-null values. So this is a very nice thing if you want to see if your data frame has missing values. Then you can use the info method here and just see that it has as many entries as is written here in each of the columns. Other thing is that it tells you the memory usage and the types, and it counts it up. In this case, we have one of each of these types here. But this data frame here that we made is rather small, so let's download a big one to kind of see it in action. So I will just copy paste what is written here. What it does is to download the iris dataset. So it goes into this web page and reads the CSV file and makes it into a data frame. And this is the well-known iris dataset, which contains information of a bunch of irises, which is a flower. Okay, so let's see it by just returning it. And what you see is that it contains 150, since we start with 0 here, different rows and 5 different columns, which is also summarized here. And since there are so many columns, Jupyter Notebook decides to not show the middle part here because it would essentially overflow the Jupyter Notebook. But let's say that we want to display the first 10 rows or the first 20 rows or so on. Then we could use the head function, which we are going to use a lot. So we can write iris.head. And if I don't write anything inside the parentheses, it will show me the first 5 rows. But if I, for instance, write 10, it will show me the first 10 rows. And I can also write a bigger number like 20, and it will then show me the first 20 rows. But let's go back to 10. So this is a more interesting data frame, and we can use describe at this data frame as well. and it will give us a lot of interesting statistical information. So here we get that the count is the same because we have 150 rows and all the data is contained. And it gives you the mean of each of these columns here. So what you get is, for instance, the mean petal width is approximately 1.2, and you get the standard deviation of each column, the minimum, the maximum, and the quantiles. A very nice feature in Pandas is that we can do a little bit of plotting using the plot functions. So if you are familiar with matplotlib, what Pandas can do under the hood is to use matplotlib for its plotting, but it has some inbuilt plot functions to make it so that you don't need to import matplotlib and do things there. So let's say that we want to make a line plot of the sepal length. So the first column up here. So then we can take the iris data frame and just choose the first column, which is sepal length. And then we can write .plot. And if we run this, it will give us a plot, so just a line plot, of all the different entries here. So let's say that we want to plot all the different columns and not only the first one. What we can do is just take the entire data frame and write .plot. And what we get out is a plot of all the different columns which are numerical in a single diagram. Okay, so in this context, making line plots doesn't really make sense because one row to the next has nothing to do with each other. The only thing is that the data frame is ordered after species, so the first species always comes first, and then the second, and then the third. So you can kind of see here that the first species has petal width down here, and then comes the second species, and then the third species over here. But let's say that we want to do a different kind of plot, for instance, a histogram of a single feature. And there are two ways to do this. First thing we can do is to take a single feature. Let's do sepal width. What we can do is .hist and run this sum. And here we have a histogram of the sepal width. Another thing we can do is to use the plot function. And then inside the plot function, we can write kind and then equal hist. And if we run this, then we see that we get a histogram once more. And you can do other kinds of plots just writing a different kind here. If you want to look more into, for instance, this plot function and just get the docstring, what you can do is to write Shift Tab inside it. And if we go to the plus sign here, it will show you the docstring of the plot method. So you can go down here and it will explain to you what all the different parameters you can plug in into here actually does. Okay, so let's say that you want a joint histogram with all the different features. Then you can just do the same as with the plot function. You can write iris .hist like this. And here you have a histogram of the sepal length, the sepal width, the petal length, and the petal width. And again, you can of course do plot, kind, and then equal hist, like this. And here it will show you also a histogram plot, but in this case it will give you a histogram where all the histograms are kind of mushed together in one single plot. So this was the introduction. So in the next couple of videos, we will actually start with machine learning.